on 2x2 or 3x3 determinants, or if you were not even here yesterday so you missed that lesson, we're still doing 2x2 and 3x3 determinants today, but with what's called Cramer's rule. And I know I said at the beginning of the chapter, and I reminded everybody when we started matrices, that the reason they're part of chapter 3 is we use matrices to solve systems of equations, and there's two methods we use for this, one being Cramer's rule. So we are going to solve systems of 2 equations and 3 equations using this rule. One thing I want to point out is, so it says we can use determinants to solve systems, like I just talked about. If a determinant is non-zero, meaning it's not 0, then a system will have a unique solution. So remember, when you solve systems of equations, you're finding the ordered pair where the lines would intersect on a graph. So you're still answering or giving an ordered pair as your answer. So if a determinant is not 0, you will have an answer, one unique solution. Otherwise, if the determinant is 0, the system will either have no solution or infinite solutions. We are not dealing with those with Cramer's rule, where you would get a determinant of 0 and have to determine, is it no solution or infinite? We are only dealing with unique solutions when we use Cramer's rule in here. So Cramer's rule uses what's called the coefficient matrix. And the coefficient matrix is a matrix for a system of equations that contains only the coefficients of the system. And remember, coefficients are the values in front of variables. So Cramer's rule, you do not have to memorize. You do not have to memorize the formula. However, even within this formula, you have to know what all of this means, and you have to know how to use it. So I just don't want somebody to get to a question either on the homework quiz or on the test and say, well, I remember Cramer's rule, I remember like I'm able to do it, but I can't remember the exact formula, and now you're not going to get the point. So I just want to see, can you use it? And so the formula you don't have to memorize. But with Cramer's rule, so it says let C be the coefficient matrix of the system. So you have a system of 2 equations. And what I want you to notice is that the coefficients of X are the first column of that matrix. And then the coefficients of Y are the second column of that matrix. And that's our coefficient matrix C. And then notice it gives the solution to this system is, and it gives you a formula for how to find your X coordinate and then a formula for how to find your Y coordinate. So what does it mean again if you have a matrix but you have the vertical lines instead of brackets? What does that mean notation-wise? The what? The determinant, what we did yesterday. So the vertical bars or vertical lines, remember, are the determinant of the matrix when they don't use the brackets. So the denominator for both X and Y is the determinant of your matrix C. So C again is your coefficient matrix. The denominator for X and Y is the determinant of that matrix. And then the numerator for each of those formulas is the determinant of a different matrix. And how to figure out what that matrix is if you're trying to find X, I want you to compare this matrix that's in the numerator with your coefficient matrix. Notice your first column, what was your X column, is now different. Your X column gets replaced with the column of constants. And then the Y column stays the same. The Y column is still your coefficients of Y. And then when you're finding Y, your X column from your coefficient matrix stays the same. But now your Y column has been replaced with your column of constants. So basically, whatever variable you're trying to find, That's the column in your coefficient matrix that you replace with your constants. So we're going to look at example 1, part A, the first system. I know the part A is cut off by the hole punch, but we're going to look at this system of equations, solve using Cramer's rule, so you can see how to work with this. When I solve using Cramer's rule, the first thing I do is I find matrix C, and I find the determinant of that matrix. So the 2 by 2 determinant like we learned yesterday. So I'm going to find the determinant of matrix C. And matrix C, to set that up, the first column will be your coefficients of x, so 7 and negative 5. And then your second column is the coefficients of y, so 3 and negative 7. And that's your 2 by 2 coefficient matrix for this system. And then to find the determinant, so now this is reviewing from yesterday, or if you weren't here, you can see how to do this. So you find your first diagonal product where you're starting in the upper left and going down to the right. So 7 times negative 7 is negative 49. And then minus your second diagonal product would be 3 times negative 5, so negative 15. And if I subtract negative 15, I'm really adding it. So I have negative 49 plus 15, which is negative 34. So you won't have to worry about this for any of the problems you're working through with Cramer's rule, but if this number was 0, then it would mean there was either no solution or infinite. But again, you shouldn't get any problems where this comes out to be 0. But now notice this is now the denominator for both your x and your y formulas, and here you choose which variable you want to find first. So I typically find x first, but you don't have to. There's a separate formula for each variable. So if I'm finding x, I'm just going to set up that formula. I know the denominator is the determinant of c, which is negative 34. And then for the numerator, I have to find the determinant of a new matrix that I have to set up. And in this new matrix, because I'm finding x, I replace the x column in that coefficient matrix with the column of constants, which is 37 and negative 41. So my first column is now 37 and negative 41. My second column, that y column, stays the same. So I keep the 3 and the negative 7. That y column will stay. So I just replaced the x column because I'm finding x. And now I have to find the determinant of this matrix that's on the top. Just like we found the determinant for the matrix C. So I have 37 times negative 7. Negative 259. Minus the other diagonal product, 3 times negative 41, is negative 123. I still have negative 34 in the denominator, and then on top I'm really adding a positive 123 because I was subtracting a negative, so I have negative 259 plus 123, so that's negative 136. And dividing that by negative 34, I get positive 4. So my x value is positive 4. And I still want you to write your answers as ordered pairs anytime you solve a system. So I have the x coordinate, I still need the y coordinate. So now to find y, I'm going to set it up a similar way. Denominator for y is still the determinant of c, so negative 34. The matrix in the numerator, though, will be different. So now because I'm finding y, yes. So now because I'm finding y in matrix C, I keep the x column the same, but I replace the y column now with the column of constants. So this would be the setup for how to find y. So now what Ethan just asked, can't you just substitute in the x coordinate to one of your equations to find y? Yes, you can. So I do not have to find y this way. If you have a system of two equations and you're solving using Cramer's rule, you have to find one of your variables using your formula. The other variable you can find by substituting that value into one of the equations. But you can find it this way. I wanted to show you this so you knew how to set up both variables. But you don't have to find y this particular way. So now if I find the determinant on the top, I have 7 times negative 41. That's negative 287 minus the second product, 37 times negative 5, is negative 185. So I'm really adding negative 287 plus 185. That's negative 102. If I divide by negative 34, the y coordinate is 3. And that's the solution to the system. So rather than using elimination or substitution, the methods we learned before, this is an alternative method. That's it. That's Cramer's rule. What? All right, and remember you can check your answers to these by substituting into both equations. So I would like you to find the solution for example 1 part B. Find the solution to that system of equations using Cramer's rule. There is a such thing as no solution, but none of the ones that I'm having you do with Cramer's rule will be no solution. So should you be getting no solution? No. Like you're not getting integers? Oh. Hold on, I can check what you're doing.
I did this like 7 times and it's not negative, so.
All right, I'm going to show, here's the answer for part B. 5, -6. Yes. All right, so for part B, I need your attention, please. I just showed how to find x, or my work just shows how to find x with Cramer's rule, and then you could just substitute it into one of your equations to find y, or you could use Cramer's rule to find y. But 5, -6. Are there questions? I know some of you weren't quite done when I walked around. Okay. Then I know some of you are working ahead, which is absolutely fine for example 2. Just make sure. Yes, so you have 3 by 3. But yes, Cramer's rule is the same. Yes. I was replaying in my mind what you asked, Jen. So for Cramer's rule for a system of 3 equations, I want you to see that this is the same setup, same process, except you have 3 by 3 matrices instead of 2 by 2. So notice you still have your coefficient matrix C. The coefficients of x are the first column. The coefficients of y are the second column. The coefficients of z are the third column. And then now you have 3 formulas because you have 3 variables, x, y, and z. The denominator for all 3 is still the determinant of your coefficient matrix C. And now, like I explained before, whatever variable you are trying to find, that is the column in your coefficient matrix that gets replaced. So when you're trying to find x, you replace the x column with your column of constants, but your y column and your z column stay the same. When you're trying to find y, you replace the y column with your column of constants, but your x column and your z column stay the same. And then when you're trying to find z, you replace the z column, and your x and your y columns stay the same. So whichever variable you're trying to find, that's the column that gets replaced. That's a way to help you remember it, not that you have to memorize the formula. I am using 4 colors, yes. The colors are meant to help, not confuse. I'm sorry if they're confusing. All right, so let's go through example 2, or start example 2. You first have to find the determinant of the coefficient matrix C. So this matrix, the first column is your column of x coefficients. That's 6, -1, and 5. Your second column, your column of y coefficients, 5, 3, and -7. Third column is your column of z. 2, 7, and negative 3. Yes, so here's what I want you all to know, first of all. If you were here yesterday and you remember finding 3 by 3 determinants, it is a process, and there are multiple 3 by 3 determinants you have to find to use Cramer's rule for a system of 3 equations. Why this could be helpful, or some of you might find this helpful, think back to your quiz that you took. When we went over solving systems of 3 equations, if you were somebody that got lost in that process of elimination and substitution and had trouble finding x, y, z, yes, this process might take a little bit longer. Some students prefer it because it is an exact formula to use. So that, in that case, it could be helpful for you if solving these before was more of a confusing process because there weren't exact steps to take. So ultimately, I just want to make sure that you understand how to use Cramer's rule. So you're understanding that method. When you find a 3 by 3 determinant, what do you have to do first?
You gotta put that.
Yes, rewrite your first 2 columns. And then I start in the upper left and find the 3 diagonal products. So the first diagonal product, 6 times 3 times negative 3. Negative 54. Plus the second diagonal product, 5 times 7 times 5, 175, plus the third diagonal product, 2 times negative 1 times negative 7 is 14. And I will be adding all those together and then subtracting the quantity if I start in the lower left and find these 3 diagonal products. The first one, 5 times 3 times 2 is 30. Second, negative 7 times 7 times 6, negative 294. Plus the last one, negative 3 times negative 1 times 5 is 15. So the first sum is 135. And then I'm subtracting negative 249. So I'm really adding 249. So this determinant is 384. So I'm just going to circle this because I'm going to be using it in my other formulas. But I have that determinant is 384. All right, so now I'm going to find x. And so again, to set up x, I know the denominator is going to be 384, the determinant of c. And then I have a new 3 by 3 matrix on top. And I start with my coefficient matrix c, and since I'm finding x, I replace the x column with my constant. So my first column is going to be negative 1, 12, and negative 52. My second column is still my y coefficients. My third column is still the z coefficients. Oops, dropped a highlighter. Questions on the setup? Okay, so now I have to find this 3 by 3 determinant. So I have to rewrite these first 2 columns. What?
There's only going to be one of these numbers.
Make the entire thing.
Well, for some, like some that weren't, if you're working ahead, I will eventually show you what this answer was. So to find x, so I have these three diagonal products. I will save us some time here because I know we're getting towards the end, but so this first product would be positive 9 plus this second product, negative 1,820 plus the third product, negative 168. And then I have to subtract the sum of my last three products. The first one is negative 312. The second one is positive 49. The third one's negative 180. And then the sum of these first three products is negative 1,979 minus the sum of the second three is negative 443. So then, yes, you would add them, and it's negative 1,536 divided by 384, meaning your x coordinate is negative 4.
That's one done.
That's one.
Nice.
Okay, I never said this process was quick, but again, realize if you struggled with these before, yes, it takes time, but it's a specific formula to use. So we still have some time. I would recommend because for these you have to find two of your variables using Cramer's rule. Once you know two, you can substitute them into one of your equations. Go ahead, try to find y or z. In the end, this is the full solution for this problem. X is negative 4, y is 5, z is negative 1. So if you worked ahead or are trying to find y or z right now, that way you can check. Practice for today is here.